Yo, it's Bogue, welcome back to KSP. The usual chemical rockets in Kerbal Space Program are great for missions to the Mun, Duna, and even the Jool system, but if you want to go further, like to other star systems and interstellar space, you're going to need even more advanced engines. Welcome to Far Future Technologies, a mod to extend your Kerbal Space Program into the future. This mod provides pretty optimistic but generally viable spacecraft technologies that might not be possible today, but the physics works out and they might be realistically feasible within the next 100 years. If you're interested in deep space exploration or interstellar travel in KSP, you're going to need to learn how to use these engines, and in this video, I will break down every engine in the mod, what kind of fuel it uses, and how to operate them. I will also be using example craft that I will include for you guys to download for free in the description below that you guys can use in your own game as examples or as a base to build your own spacecrafts off of. So let's get right into it. To get started, make sure you have Far Future Technologies installed and all of its required dependencies. Some notable dependencies or recommended mods that I think you should have are heat control, which adds futuristic radiators, system heat and cryo tanks, these two should be included in Far Future Tech, and near future electric and near future construction, but I also recommend the other near future tech mods as well. You're also going to want Kerbal Engineer Readout for more accurate stats about your spacecraft. I'll also drop a link down below to a recent video I did where I break down all of the coolest mods for KSP that I have installed, which also has a link to my full mod pack and install guide for a bunch of these mods. So Far Future Technologies has three main engine types. The first is fission engines, which split atoms to produce their propulsion. The first engine and example craft we'll be taking a look at is for the X6 Caviar Fission Fragment Rocket Engine, which is effectively an open fission reactor core. Here it is on my example craft, and you can find it here. You can look it up and read a bunch more about it. And for this first craft, I'll also break down how to read the engine stats that you can see in this side menu here. So first we have the alternator output. This is basically the electric charge that the engine will produce per second while it's running. This engine produces 75 units per second. Next is the level of thrust at sea level and in the vacuum of space. This engine provides 12 kilonewtons of thrust in space, but none in sea level, so it needs to be in space to operate. Next is the engine ISP, or specific impulse, which is essentially a measure of how efficient it is. The larger the number, the more efficient the engine, and the longer that it could burn for any given amount of fuel. Next is the propellant. This one uses enriched uranium. This part is unique in that it can't drain from other tanks, so all of its fuel is carried within the part itself, and once it runs out, it can't be refueled. So the range of this engine has an upper limit, but it can still go super far, and the other engines don't really work like this. So next is the engine's heat production. So it has 15 megawatts of waste heat, and this will need to be actively cooled with radiators. We'll talk more about that in a second. Taking a look at the craft, we have this reactor here in the middle. This is the Prometheus fission reactor, and basically what we're using this for is to generate electrical power. It generates 2,000 electric charge per second, and I include it because generally, for these Far Future engines, you need a lot of electricity to run them. These generators also have waste heat, 4 megawatts there, and this will need to be cooled as well. So now we'll talk about radiators. So radiators are these big black panels I'm pointing out here. These are added by the mod Heat Control, and they're basically giant fans that heat up and radiate heat away from the spacecraft to cool engines and generators. To see how much heat you're producing and how much heat you're removing with your radiators, go to this panel down below that looks like a little flame and a gear. This is the heat management panel. We can see that we're generating 19 megawatts of heat and we're removing 19 megawatts of heat. You can also see that I have two loops, which are basically channels to assign specific radiators to cool specific parts. On this craft, I have two loops or channels. You can see that both channels have a negative flux value, which means they are radiating more heat than they're generating. I have assigned the larger radiators and the engine to this loop, and the smaller radiators and generator to loop 1. You can use this heat management panel to see if you need to add more radiators to cool your craft at any given point. You can assign radiators, engines, and generators to these loops by left-clicking on a part and setting the loop here with the arrows on either side to cycle through the different loops. Another thing that you'll notice is that your staging display might read that you have 0 delta V, which is a measurement of how much change in velocity you can achieve with your spacecraft. This is obviously not accurate, and the reason is that the stock delta V calculator here stops working after a certain amount of burn time. And since this engine will burn for so much longer than any of the stock engines, it's not really equipped to calculate the delta V accurately. For this, we will use the Kerbal Engineer Readout mod, which you can activate by clicking on this wrench tab down below, which will open a display of stats about your craft that will be more accurate. We can see here that this craft has more than 94,000 meters per second of delta V. Cool, so these are all the readouts and stuff in the VAB that you will need to know for building spacecraft with far future tech engines. And now that you know what these mean, we can go through the different engine types much quicker. But first, let's cheat this craft into orbit real quick and check out the engine in action. Alright, so you open the cheats menu on the launch pad and click set orbit. And I've just put us into a high orbit above Kerbin. And we'll right click on our parts to make sure that our radiators are on and enable our reactor. Now we're generating electricity, and you can scroll down to your heat management tab to see that you're removing more heat than you're generating. And we'll go ahead and activate this engine, and we can throttle up. And yeah, you'll see those radiators start to glow red as they've started to heat up and radiate the heat away. And you don't actually have to keep your reactor on the whole time, which is why I just turned it off, because this engine does generate its own electricity. And look down below, you can see that we're not accelerating very fast. This is one of the limits of this engine. It's almost like an ion engine in that way. So a lot of your burns will take quite a bit of time, which is why I recommend either the mod Persistent Thrust or Background Thrust. Two mods that allow you to burn during non-physics time warp. You can see that I'm warping quite fast, but still burning. Our delta V is decreasing. So yeah, you can burn for like days on end. It looks like we ran out of fuel at about 10 days straight of burn time. So it went by quick, but that's because we were doing the non-physics time warp. And just to see like how fast we ended up going, we just crossed Elu orbit and it's only been 43 days. So we're already on an interstellar trajectory with these guys, and we'll check out the next engine on our list. This is the X7 Asimov Afterburning Fission Fragment Engine, and it's an advanced fission fragment engine with superior capabilities to the previous one. It has an afterburning mode for additional thrust as well. Here's the example craft in the VAB. It produces 150 electric charge, engine ISP is 450,000, uses fragment pellets, or just called frag. It uses this tank, NTS-002 fissionable tank, I think. What is it called? Yeah, so these two tanks here, they have two modes, and you switch it to this one. That's fissionable particles, but it's called frag in the fuel bar. There's a couple different tanks you can choose from that also carry nuclear saltwater as an option for a different engine later. One thing that's cool about this engine is multi-mode, so it has an afterburning mode that you can use with LH2. So let's grab an LH2 tank real quick. They're in these gold-looking tanks all around here. We'll put one on there. Actually, that's a little big. We'll put a smaller one on there. Make sure to switch it to LH2. There's a couple different variants of these tanks that carry like different combinations of like LH2 and oxidizer. So in the normal mode, it's just going to use those frag pellets, and in the second mode, it'll use the frag and the LH2 for added thrust. So it's kind of like injecting nitrous in your car engine or something like that. You get a little bit more thrust, but it looks like the heat parameter is different per mode. If you ever want to check how much electricity you're generating versus consuming, you can click on that little battery panel and it'll show you your energy consumed and your energy produced, and you can make sure that you're in a net positive there. We're using 3 pairs of these advanced radioisotopic generators as our RTGs from the Near Future Electric mod, I believe, or they may be from Far Future. I recommend both of those mods. And with our 4 radiators, and we take a look at our heat loops, we're generating 16 megawatts and removing 17 megawatts with a single loop, since we don't have a big generator on this ship. Another thing that you can do with these radiators is you can select different sizes, and that will affect how much heat you're radiating away depending on size, but that's a good option to customize your radiators. I also have probe cores on all of these craft so that I can control them remotely. Pretty simple startup for this engine. You just got to make sure your radiators are on and hit activate engine and throttle up and you're good to go. Yeah, so this one's a good engine, pretty high delta V. One of the benefits of this engine over the last one is that it doesn't have a top ceiling because you can always stack on more fuel as long as you have a positive TWR. And it has that afterburning mode, which we'll take a look at in a second. So the main mode uses these fragment pieces, and then the second one is LH2 and frag. So if we toggle mode here, you can see the plume gets a little bit bigger and our thrust is much higher. So we're picking up speed way faster basically. We toggle back to the original mode, much slower, and toggle mode again, much faster. But yeah, I guess our efficiency will be lower because we have more weight, because we're using 2 fuel modes. And when you're using engines with multiple fuel types at the same time, you gotta balance the fuel types since they'll use them at different rates. I'll show you guys how to do that later on, but we'll go ahead and move on to our third engine type, which is the X20 Verne pulsed fission engine. So here we are in the VAB, and you can see that we have much more radiators for this one because it generates probably more heat. But another thing to note about this one is that it requires a startup charge. So we have to charge the engine before we can start it up. As you can see right there, it has a ISP of 9,500, so it's not nearly as efficient as the other ones. It uses fission pellets for fuel, which are contained in these nuclear pellet storage containers, which I'll pull up here. We have a few different sizes to choose from. We're using that same Prometheus fission reactor again for our electricity, and for our heat management we're generating 17 and we're removing 23 with a single loop. That means we have all 4 of our radiators cooling the engine and the reactor at the same time. It's sometimes better to put the engine and the reactor on separate loops like I showed with the first engine, but sometimes when you have an excess amount of heat that you're generating away, you can get away with just one loop. So I'm just making sure that my radiators are on, and we'll hit enable reactor, and that's starting up our reactor. So we need our reactor because we have to charge up our engine. So once we're ready to do that, we'll click on the engine, and here's your charge rate. You're gonna have to turn that up so it doesn't take forever to charge. You can see just how slowly that's charging. I guess that's if you're not generating as much, you can have that set to a lower rate to accommodate the amount of electricity you can generate per second. But here we have it fully charged, and once that's done, all we have to do is activate the engine, and it looks like it's shutting down because our throttles drop below 5%. So this one, the throttle needs to be up, I guess, at all times, or it's going to deactivate the engine. And there we go, we've activated it. And so the way this thing works, it's a pulse engine, so it kind of releases these individual detonations behind it, and that's what's producing the propulsion. It's almost like the Orion drive, if you've ever heard of that, which uses nuclear bombs behind it to push it along with a spring-loaded pusher plate. Anyway, we actually have one of those later on, so stay tuned for that. But you can see that we have a fair amount of thrust with a TWR of 0.6 about. That means you could definitely tack on a bunch more fuel here. And I just turned off the reactor to see if I need to keep that on the whole time, and our electricity is going down, so I think that means that we do. I turned the reactor back on. So this engine also consumes electricity in addition to the fission pellets. Next we have the X2 Heinlein nuclear saltwater engine, which is pretty cool. It's a very high thrust engine with very interesting fuel. So I guess it's like nuclear saltwater. And anyway, it's a real concept, believe it or not. But let's take a look at the engine here. It says basically a barely contained nuclear explosion. Highly radioactive, but highly awesome. It's got really high thrust, 1800 kilonewtons. And it works in the vacuum and in at sea level. It uses about 25 electric charge per second and nuclear salt water. But it also gives off a lot of heat, 8 megawatts for this particular engine. And we're also using this smaller reactor here to supply the electric charge, the Garnet fission reactor. Yeah, so that produces, yeah, it has like 800 kilowatts of heat, so less than a megawatt. And we have two loops going on, one to the bigger radiators to cool the engine, and the smaller ones on a separate loop to cool the reactor. Yeah, and that's basically the craft that we've got set up. Both of them are in negative heat flux, which is good. These nuclear saltwater engines have much higher thrust than the other engines I've been showing. Like, we're currently at 2.63 TWR, which means we can keep adding fuel till we hit kind of the limit of how much delta V we can get out of this thing. You can see that now we're under 1 TWR, but we can get up to like 30 to 40,000 meters per second of delta V. So let's test this thing out. Let's move on to the big brother of the nuclear saltwater engines. This is the X42 Niven saltwater engine. Anyway, we've got these much bigger saltwater tanks here, and you can see just how much bigger this engine is. Let's go ahead and take a look at the stats. So, engine provides an answer to life, the universe, and everything. Pretty cool. Takes like 90 electric charge and nuclear saltwater, but gives off 50 megawatts of heat. So that's why we have all these radiators. I have that reactor there in the middle. I kind of sandwiched it in between these smaller radiators, which are on a separate loop to cool it, and then the bigger radiators are on a separate loop to cool the main engine, as you can see there. So let's go ahead and test it out. But you can take a look. We have 1,000,000 delta V already. This engine is pretty efficient. Let's go ahead and turn on that Prometheus fission reactor. We're getting our electric charge now, and we turn on the engine and fire it up. And you can see those radiators begin to glow red as they're getting rid of all that waste heat. And yeah, this one is one of the better engines in the fission category, probably the best one, I would say. All right, let's take a look at the last engine in the category of fission. This is the Hamilton nuclear pulse engine, also known as the Orion drive. So a lot of you guys in the space exploration fandom might know of this engine, which was it's basically an engine that just lights off nukes behind it, and it has this giant spring-loaded pusher plate that propels it forward from the blast itself. The fuel type it takes are these nuclear pulse unit tanks. We've got a couple here in different sizes you can choose from. But yeah, this engine is pretty cool. It's super heavy though, so you're gonna need really, really big launch vehicles to get this thing into orbit. But once you do, it's super easy to operate. No electric charge required. Just throttle up and watch the madness happen. Pretty cool, huh? I did a mission video where I made a Duna Express spacecraft that could get to Duna in like less than a month with this engine. Pretty cool. I'll drop a link there. But yeah, this thing is pretty cool. Let's check out the next category, which is fusion engines. So instead of knocking atoms apart, you're fusing atoms together and you get a bigger energy return. And so our first fusion engine is the JP10 Impulse Magneto-Inertial fusion engine, which is like an entry-level fusion pulse engine delivering the capabilities of high-end ion engines without the amount of power required for a similar result. So here's our example craft. We have the engine down at the bottom, and we'll pull up the stats real quick, take a look. So yeah, there's the description. Requires 2,000 electric charge to charge it up, but it provides 75 kilonewtons of thrust. ISP is 5,000, but it runs on lithium and liquid deuterium as well as electric charge. So this engine is going to need multiple fuel types. Pretty cool. It also has another mode where it uses H3, helium-3 in addition. So you have our two lithium tanks here. Here's what those look like. You have a selection of those. And then these are fusion fuel tanks. They carry liquid deuterium and liquid hydrogen-3. And you have three different modes, like you can carry both or you can carry one or the other. They come in these fusion fuel tanks here. Like you can do deuterium, helium-3, or both. I just have one tank set to deuterium, and then I have another tank set to deuterium and helium-3 for the afterburning mode. And for the heat management, it makes 7 megawatts with these two, and it looks like my loop with the generator was too hot, so I increased the size of the radiators connected to the generator, and now both loops are in a negative heat flux. Anyway, that's the heating setup. Let's get this thing into orbit. Okay, so here we are in space. Let's enable that reactor and turn on the charging for our engine. And we're fully charged, so we'll throttle up and start the engine. And so it kind of works almost like the Orion engine in that it's a pulse engine, but it's using that lithium fuel and the fusion fuel made up of helium-3 and deuterium to make its propulsion, which is pretty cool. Another thing to note is that most fusion fuel tanks and hydrogen fuel tanks require a certain amount of electric charge per second to keep them from evaporating. Just one other thing. And I just switched the toggle mode, so we're in our afterburning mode. So now we're using that extra helium-3 tank, and we're getting an increased amount of thrust with the afterburning mode. So all the engines that have afterburning modes will usually just like increase the thrust, but you'll get slightly less delta V because it'll be less efficient. But that's the JP10. Let's check out our next engine, which is the JR15 Discovery Spherical Tokamak Fusion Engine, which is magnetically confined fusion and a good all-arounder with an integrated power reactor and additional afterburning thrust mode. So we'll take a look at the craft. And here it is. So it's a larger engine, but we'll take a look at the stats. So it produces like 200 kilonewtons of thrust, and the ISP is about 18,000 in vacuum, and it runs on liquid deuterium and liquid helium-3. Those will be in the fusion fuel tanks, and LH2, liquid hydrogen, which will be in the hydrogen fuel tanks. And it looks like it has multiple modes. The second mode is only 8,000 ISP and runs on the same fuel types, but like you can see with the ISP, it's less efficient. It also has its own internal generator, which puts off about 1,500 kilowatts after you've charged it up. And this runs on deuterium and helium-3 as well. But the first mode puts off 14 megawatts of heat, and the second puts off 7 megawatts of heat. So we have this flat fission reactor here. This is going to be providing our power. Let me find it here. It should be in the electric panel. Oh wait, I went past it. There it is, right there. Yes, and so the generator produces 2,000 EC per second and puts out 3 megawatts of heat. And so and this is our LH2 tank. Make sure you're on this second mode here so you're not including oxidizer as well. And for our fusion fuel, we're carrying both sets of a mix of deuterium and helium-3. And our delta V, we have about 32,500 meters per second of delta V with this current setup, and we're at about 0.45 TWR, so you can definitely tack some more fuel onto this. And I want to show you how you can maybe tack some more fuel onto this. So let's switch that to LH2. So our TWR has gone down, but our delta V has increased. So you can do this with like basically any of the crafts that I've got on here, but you can see after a while that the delta V will start to go down at a certain point. And this is where I can show you how to figure out the optimal mix. So since this runs on 3 different fuel sources, if like I add too much LH2, you can see that my delta V doesn't necessarily always go up when I add more LH2. At the transition point, when adding more fuel of one type doesn't necessarily increase your delta V, that's the point at which your fuel is balanced. So you can use Kerbal Engineer to figure that out. So like if I keep adding LH2, at a certain point the delta V readout will stop increasing, and that means that I've met my balance with the other fuel types. And if you want to keep increasing, you're going to need to add more of the other fuel types as well to keep that delta V going up. Hopefully that made sense. That's just a quick way that you can use to balance engines that have different fuel types. And we'll take a look at our heat parameters. So we're generating 19 megawatts, we're removing 22 megawatts. So we're got a pretty good margin. I only have one loop because we have, a pretty high, negative flux. So I didn't think we needed more than 2 loops to separate them. And here we are in space. Let's try this thing out. So we gotta turn on our reactor. We're generating electricity and make sure that our radiators are on as per usual. And this engine is going to require charging. So you have to turn up that charge rate and enable charging. And then once it's fully charged, you can enable the reactor. That's producing its own electricity now. So you can kind of actually turn off your other reactor if you want. So that's what I just did there. Make sure that your electricity is not going down, and you can just run on the internal reactor on the engine. And let's turn that thing on. Yeah, so we're firing in our first mode now. We've got a 0.44 TWR, and we can toggle the mode, and you can see that our thrust rate has increased. So that's pretty cool. But our delta V does go down, so it's almost half as efficient on the higher thrust mode, but there might be some circumstances where you need that extra thrust fast. And our next engine is the JR45 Fresnel Mirror Cell Fusion Engine, and this is another magnetically confined fusion engine with high power and low power mode. So it's got two modes. It also has toggleable size variants that make it shorter or longer, and the longer it is, typically the more efficient it would be at the cost of lower thrust. So let's take a look at our example craft. Here's the engine, and we'll pull up the stats. So it has an ISP of about 63,000 in vacuum. It runs on liquid deuterium in these fusion fuel tanks, as well as hydrogen-3 in the same fuel tanks, but it also has an afterburning mode at 14,000 ISP, where you can inject liquid hydrogen, which is in those orange fuel tanks, to get a similar effect before, where you can get higher thrust at the cost of less efficiency. And the fusion engine requires a startup charge, and it has its own internal reactor before that generates electricity that also takes fusion fuel. And the waste heat is usually 24 megawatts, but in the second mode it's 15 megawatts. Let's take a look at the fission reactor that we're using. It's that flat fission reactor from before. We're basically going to use that to charge it up, and then we'll run on the engine's internal reactor. And we'll take a look at our heat situation. We have 28 megawatts produced, and we're down 30 megawatts in cooling on a single loop. And to get it started, we'll turn on our reactor. We're generating electricity, turn up the charge rate on the engine, and enable startup charging. And once that gets to 100%, looks like it takes a little bit longer than the other ones, you can enable its internal reactor, where you're generating electricity on the engine alone. You can disable your original reactor that you used to charge it up. The engine's internal reactor also consumes some of this fusion fuel here, a very small amount, but you can just activate the engine and throttle up, and you're going already. We'll see those radiators start to glow red as they radiate heat away from the craft. You can see that currently we have like 78,000 meters per second. And yeah, our TWR is 0.13, so it looks like we don't have a ton more fuel to add if we want to keep that TWR above 0.1. But if we switch to that afterburning mode, we're using that extra LH2 in the golden tanks for an extra bit of thrust at the cost of efficiency. So yeah, that's basically this engine in a nutshell. You can also experiment with the different lengths of the engine, the toggleable lengths, to see if you can get more efficiency out of that and extend its range. Yeah, pretty cool engine. The next engine in the fusion category is the K80 Hammertong Inertial Confinement Fusion Engine. And this uses laser-based inertial confinement of fusion fuel to generate its propulsion, which is pretty cool. I also think it's one of the cooler looking engines in the mod. Here it is down the middle, and we'll take a look at its stats. So it requires 20,000 electric charge to charge up. It has about 500,000 ISP, which is pretty efficient. Runs on liquid deuterium and liquid helium-3 in those fusion fuel tanks, those big spherical ones. I'm carrying that deuterium and helium-3 mix. And it has a second mode, which has less, about like half the efficiency. Runs on less heat, but you probably get more thrust. So our heat situation, we have these big radiators down the sides. That's cooling the engine, and then we have these two in the middle that are charging our flat fission reactor from before. And we have 34 megawatts generated, and we're removing 45. We have those two loops that I just talked about before, but we're going to turn off that fission reactor once this engine gets going, so it doesn't matter that I'm on a slight net loss or net gain of heat on that loop, because we're just going to be shutting it off after a short amount of time. Not a big deal. So we'll enable that reactor, which is just for charging this engine. We'll turn up the charge rate and enable charging. And yeah, once that hits 100, we'll use the engine's internal reactor to generate power. So we're at 100. Let's activate the engine. And it looks like it needs to be throttled up to run. So we're probably going to wait till it charges again and activate that engine. And there you go. You've got it running. It has a really cool plume animation where you can see those lasers, which basically beam down on fuel and squishes it so hard that it fuses together and releases that fusion energy. If we want to switch to the afterburning mode, it'll have to charge up again, like charged completely back up to 100%. And then we can activate the engine again. And so this is in the afterburning mode where we're getting like double the thrust but less efficiency. And I'm going to try to turn off that reactor and see that if we're losing electricity. It looks like we are, so I'm going to actually keep that original reactor on. I don't think this engine is very powerful in thrust, but it's pretty efficient. And so you can toggle it back to the original mode, start it up again, and it looks like we already have like 1,000,000 delta V, which is pretty good. But we have very low TWR, like 0.05. So yeah, it may not be the best torch engine, but it's pretty efficient nonetheless. The next engine in the fusion category is kind of an outlier because it's the only one designed for atmospheric use. This is like an Aerospike type design. The JR-20A Ouroboros Toroidal Tokamak fusion engine is designed for launch vehicles. It's basically a miniature fusion engine with an Aerospike. So let's pull up the example craft. Here's what I made. It's got some fins on the bottom for stability of flight in atmosphere, and we've got a capsule on the top and the Ouroboros engine on the bottom. Let's take a look at its stats. So it's a magnetic fusion engine, has about 1,900 ISP in vacuum. So it's much less efficient than the deep space type engines that we've been looking at, but it's high thrust and still fairly high ISP compared to like normal chemical rockets, make it a really powerful atmospheric like launch type engine. It runs on LH2 and liquid deuterium and liquid helium-3, so those are those fusion fuels, and the hydrogen fuel. It requires a startup charge of 3,500 electricity, and the engine also has its own internal reactor that uses the fusion fuel, and generally when it's running it'll have like 8 megawatts of heat coming out of it. So we're using these RTGs on the sides here to charge the engine, and here's our big LH2 fuel tanks, and in between this like little cone here are those fusion fuels, and we have our capsule on the top. The biggest challenge with this engine is figuring out how to fit all the radiators on it and cool it. So this is generating 8 megawatts, but all of these radiators around it have a negative 11 megawatt cooling effect. So let's get it out to launch. So we gotta click on it, enable that charge rate up to 100%. It kind of charges slow with our low electricity generation, but once we enable the engine, it should have its own internal reactor, and we can just throttle up, and you can see just how moving this thing is, like it's hauling. This is going so fast, we're probably going to burn up in the atmosphere just of how fast we're going, so we can definitely throttle down. And if you believe it or not, this entire craft can get well into orbit on just one stage. So this is another engine that may be like best suited as a lander or maybe even like a launch vehicle engine for exploration. This is not the one that's going to be like your mothership engine in deep space, but it's going to be really useful for launching and landing on atmospheric bodies or even vacuum bodies. It's still pretty efficient on vacuum bodies. And one of your other challenges is going to be how to stack enough hydrogen fuel on there, because the liquid hydrogen is kind of not super dense, so you have to have like a big form factor to fit enough fuel on it. Like even though this is fairly small for a launch vehicle, it's still kind of big for a lander. Anyway, those are just some things to consider. A very unique engine. Next is the JX200 Cascade Axial Flow Z-Pinch Fusion Torch engine, which compresses fusion fuels using zeta pinch techniques, whatever that is, resulting in excellent fusion gain without the mass of a magnetic fusion chamber, and it has an afterburning mode for additional thrust as well. So I think this is the torch engine of the fusion category, meaning it's really high efficiency and high thrust, probably the best one in the group. And this is the example craft. We'll pull up the stats of the engine. So this engine has its own generator, which produces 750 electric charge per second, needs to be charged up, and it has an ISP of 365,000 in vacuum, and it runs on liquid deuterium and liquid hydrogen 3, both contained in the third mix option of this singular fusion fuel tank. Its afterburning mode takes extra LH2, but your ISP is going to be down to 85,000 ISP, and your first mode 54 megawatts of heat, and your second mode is 36. To charge it up, we're using that flat fission reactor that we've been using, And taking a look at our heating situation, we're producing 57 megawatts, we're moving 58 in 2 loops. So we have these top ones cooling the reactor on a first loop and the rest of the radiators on a second loop cooling the engine. So let's try it out. To operate it, we'll turn on that reactor, get the electricity going, and then we're going to have to turn up the charge rate and enable startup charging. And once that reaches 100%, we're going to be able to enable the engine. And it looks like it shut down if the throttle's too low. So we're going to throttle up and try again. And there we are with our activation. And look at that beautiful plume that you can see through the engine frame itself. That's pretty sick. In our base mode, we're at 1.55 TWR, so we can definitely tack some more fuel onto this, and we're already at 400,000 meters per second of delta V, so this engine's pretty good. This first mode runs just on the usual fusion fuel, that deuterium and helium-3 mix. The afterburning mode takes some extra LH2, but I didn't add a tank of that on this example craft for whatever reason, but it has the same effect as the other afterburning modes, so you get extra thrust for less efficiency. That was the last of the fusion engines, which brings us to our third category, the antimatter annihilation engines, which basically take a particle of antimatter and a particle of regular matter and smash it together where they completely annihilate, almost turning their entire mass completely into energy. So it is the highest efficiency fuel/propulsion type for the far future technologies engines. So the first one we'll be looking at is the A7007 Dirac antimatter initiated microfusion engine, which exploits the multiplicative power of antimatter to induce fusion with a far lighter and less complex system than inertial or magnetic confinement. So it's kind of like a fusion engine with some antimatter catalyst in there to bump the efficiency and the power. This is the example craft I have pulled up, so we'll pull up the engine and take a look at its stats. It has an ISP of 115,000 in vacuum. It takes antimatter fuel and fusion fuel, which is made up of that liquid deuterium and helium-3 mix. It has its own internal reactor and requires a startup charge and puts out about 4 megawatts of heat. To store the antimatter, we're using this ACY125 antimatter storage container. There's a few different antimatter storage containers here, and the way these work is they basically magnetically confine the antimatter. Because if it comes into touch with any other matter, it's gonna freaking explode. So you need to spend some electricity per container to keep that contained, or else your entire craft is gonna not exist. And you can see in the stats of these different containers the amount of electricity per second it costs to contain it. We're carrying a small amount of antimatter in addition to this deuterium helium-3 fusion fuel mix. If you ever want to see the use and generation of your electricity, you can click on this battery and you can see how much you're generating versus how much you're consuming per second. That includes the antimatter storage cost. And on this craft, to generate electricity, we're using that fission reactor, the Prometheus fission reactor. And it looks like our first loop is actually gaining some heat, so we're going to increase the size of one of these radiators. And yeah, so we're doing a similar thing before. One loop of radiators, so that first group of 4 is cooling the reactor, and then the other ones are going to be cooling the engine on separate loops. And once you've launched, make sure to turn on your reactor quickly, because you'll run out of electricity to contain the antimatter and you'll explode. Make sure to turn on your radiators, or make sure they're running, and we'll enable that charge rate and start charging the engine. Once it's fully charged, you can activate it and it'll start generating its own electricity as well. And it uses a pulse style propulsion, so it's basically combining the LH2 matter and the antimatter, and it's creating these mini explosions behind it. We have a TWR of 0.18, which means you could probably stack some more fuel on here. I recommend probably not going below 0.1 TWR if you can help it, because your burns will just take forever. And currently we have about 41,000 meters per second of delta V. So not the best antimatter engine, but still pretty good. Okay, the next engine is the A134NG Cascade antimatter catalyzed fission engine. This huge engine fires bursts of antiprotons into subcritical fission targets, producing a large explosion that propels the craft. And here is our example craft. We'll pull up the engine stats. It requires a startup charge, and its ISP is 13,500 in vacuum, and it has its own ablator inside it that can't drain from any parts, so this engine will have a total ceiling that it can't surpass. But other than that, it uses antimatter and fissionable particles, which are contained in this PWX8 nuclear pellet storage container. I think when you click on it, the fuel type will read as FIP, as well as antimatter, stored in this round orange tank here. And this engine also uses its own ablator, which you can't tack any more on here, but it's all contained within the part itself. Once this runs out, your engine's not going to work anymore. So that's what I mean by saying it has a top ceiling that you can't really surpass. We're using that flat fission reactor we've been using before, and our stats right now, TWR 0.51 and 61,000 delta V. So you can definitely tack some more fuel onto this, but like I said, there will be a top limit because of this ablator that will run out eventually, no matter how much fuel you put on there. As for heat, we're generating 14 megawatts and removing 18 megawatts in 2 loops. These top 2 radiators are cooling the reactor, and the bottom 2 are cooling the engine in 2 separate loops. And once in space to get started, we'll enable that reactor, and once you're generating electricity, turn up the charge rate and charge up the engine, and then you can hit activate and throttle up. Now this is a pulse type engine before, so it's creating those explosions behind it. The plume animation is super cool. Looks like it has a bunch of lasers coming out to catalyze the antimatter and fusion fuel. I'll say it again just in case, but this is pretty useful. If you ever want to check your electricity or heat rates, make sure that's all in order. You can go to these panels down below and see your heat removal and the amount of electricity you're generating versus consuming. Monitoring those will make sure that your ship is working correctly. That brings us to our last antimatter engine, the A834M Frisbee antimatter torch engine. And this engine reacts a considerable amount of antiprotons with liquid hydrogen, producing a multi-kilometer long beam of energetic particles, resulting in excellent thrust and specific impulse. If you've watched my channel in the past, you might recognize this engine from some of my other interstellar vehicles, like the KSS Bova, an ISV I designed to explore the Aethera system from the Kerbal Star System's 2 Interstellar Planet Pack, or my ISV Venture Star recreation from the Avatar movies. This engine is basically the endgame engine for the Far Future Technologies mod, and is, in my opinion, the best. So we'll pull up the example craft, and first thing you'll notice is that it's huge. With the mod Hangar Extender, you can get rid of the VAB and see, outside of it, so that you can build much larger spacecraft, and that's what I have to do here with this example craft for the Frisbee. Here it is. We'll pull up the engine stats. It provides 80 kilonewtons of thrust, runs on antimatter and liquid hydrogen, and its ISP is 2.5 million, so it's insanely efficient. But it would also usually have an insane amount of waste heat at 360 megawatts. But there's something interesting about this engine. It has different length variants that add extra mass, but with each increment of added length, it produces less and less heat. And in the largest length variant, it completely self-eliminates its heat generation. So in this longest variant that I have here off to the left, and the one that I have on the ship, the engine itself is generating 0 waste heat. So that's something cool. It runs on liquid hydrogen, which is contained in these white fuel tanks. And the antimatter tank I'm using is this small ACY1 antimatter storage container. Now you might wonder, this thing looks tiny. How are you going to have enough antimatter to match with the LH2 that you got on board? And this is because I have another part, the PK50 Nova antimatter facility, which is basically its own antimatter factory. So you can use this part in addition to a bunch of electricity, one or both of 2 fuel sources, and the required cooling to manufacture your own antimatter in flight. And one reason this is useful is that antimatter costs a lot of electricity to keep contained, like I was mentioning earlier, so there's less risk of loss of containment and total annihilation, and you can save on some space on your ship where you don't have to have as many antimatter fuel tanks. And it can convert 2 different kinds of fuel into antimatter, and you can left click on the part and see start light elements factory or start heavy elements factory. And light elements is actually LH2, which we've already got on board, and heavy elements is nuclear fission pellets. So these are contained in the nuclear pellet storage containers. They're called FIP, fission pellets. And this fuel type is way more efficient than the light elements. You'll produce much more antimatter per second with the fission pellets than with the LH2 fuel source. In fact, the fission pellets, the heavy elements generation, will produce enough antimatter to supply the consumption needs of your engine in flight. So if you have your antimatter factory running and your engine running at the same time on the heavy elements factory mode, you'll always have enough antimatter. I don't think the light elements mode using LH2 provides enough antimatter per second to keep up with the consumption of the engine in flight. I'll show how this works later, but definitely include some fission pellets for your factory. Let's look at the heating situation. So I have 4 loops currently. We're producing 28 megawatts of heat and removing 56 megawatts of heat. I think it's pretty good to have an excess of heat removal when you're using the factory. And the way we're powering this is using the FX3 fusion reactor. This is probably the best reactor in the mod. It runs on a small amount of fusion fuel, that's deuterium and helium-3, contained in the white spherical tank at the top of my craft. This fusion reactor actually needs its own startup charge to activate, so I actually have a third backup reactor to do that, but it produces up to 20,000 electric charge per second. Here is that backup generator / the generator that I'm going to use to charge the fusion reactor. It's that flat fission reactor that we've been using for the past couple craft. Yeah, so that's what I use to charge the fusion reactor, the main reactor, and then the main reactor is what I use to run the antimatter factory and the main engine. We'll take a look at the heat management. So we're producing 28 megawatts of heat, removing 56 megawatts of heat. I think it's probably good to have an extra, deficit for this. But I basically have 3 different loops. So the first loop is the antimatter factory. So it's these bottom radiators are on the first loop. Second loop has the second row of radiators, which is cooling the fusion reactor. And then the third row of radiators is cooling the fission reactor. So those are the 3 loops I have broken down. I actually have a 4th loop that I have connected to the engine, but like I said before, the engine isn't creating any heat in its longest variant. So we'll zoom into this thing on the launch pad and we can see just how humongous it is. Once in orbit, we'll start our smaller reactor to charge the fusion reactor. Once that's charged, you can enable the main reactor, the FX3 fusion, and then you can right-click on the antimatter factory and click Start Factory Heavy Elements, which is going to start turning those fission particles into antimatter to keep your antimatter tank fully stocked. Next, you can activate your main engine and throttle up, and there you are, you're moving. Currently we have a TWR of 0.64 and we can tack on a lot more liquid hydrogen before that gets any lower. And you can see that our antimatter is actually replenishing as we burn. That's because of that antimatter factory. These things right here, the fission pellets, that's what's going to be consumed to make the antimatter. And then the antimatter is combined with the liquid hydrogen to annihilate and produce the thrust. And you might see up here that it says that we have 27,000 meters per second of delta V. This isn't actually true because it's just calculating that off of our current supply of antimatter, which because we only have one tank is nowhere near the actual amount of time that we can burn because we're going to be constantly refilling that tank. So to figure out just how far this thing can go or how fast it can go, which is essentially a measure of its delta V, we're going to just time warp ahead while burning. You can do this using the mod persistent thrust or background thrust, I've heard, until we run out of fuel. So you can see just how long we're accelerating and Kerbin shrinking behind us. You can see that our delta V is actually increasing under the Kerbal engineer readout thing, and there's Kerbal shrinking rapidly behind us. It's only been 5 days of continuous burning if you look at our clock. So we're rapidly accelerating out of the Kerbal system. And something you might run into is that your time warp with persistent thrust might stop at some point at a certain level of time warp because it thinks you've run out of electricity. So it's kind of halting my time warp every time it thinks that's happening. This is just one of the quirks of persistent thrust. I'm not even entirely sure if this is a bug with, far future or anything like that, but you'll find your limit. Like, I've found that this level of time warp is the max level of time warp it will do without interrupting me, basically. But if you look at our speed down below, we're already well over 3 million meters per second of delta V, essentially, or speed that we've achieved. And this is actually a really great cruising speed already to reach another star system if you're using like an interstellar planet pack. Right now I have Cosmic Serenity installed. We'll zoom out. You can see just that's Kerbal behind us, and we've only been burning about a month, so we're going wicked fast. You can see these 2 interstellar star systems added by Cosmic Serenity, one of my favorite interstellar planet packs at the moment. But yeah, we've already reached like almost 6 million meters per second of delta V, which is going to get you to any interstellar star system within 1 or 2 decades or less, which is pretty good. I should also mention that this plume that you see, this giant blue plume of plasma behind the ship, is from Interstellar Plumes, another mod that modifies the original plume that comes with Far Future Tech, which is more of a purple, and I don't think it's as long. This mod, Interstellar Plumes, just adds this different look to it to kind of match the antimatter engines from the Avatar movies. So yeah, the one that comes stock with Far Future Tech will look like this. But if we look at our nav ball speed here, we're already at like 8 million meters per second of delta V, so we're going insanely fast. If I shut off my engine here, we're so far away from Kerbal, we can't even see it anywhere. Like, we are in the middle of absolute nowhere, and we're going really freaking fast, a significant fraction of the speed of light actually. And we still had plenty of liquid hydrogen fuel and fission pellets left over, so this craft can go really far, and all of these spacecraft files will be included below that you guys can learn from, use as examples, or modify to build your own craft out of with the Far Future Tech mod. I usually play in sandbox mode, which means all fuel modes are free, but antimatter in, I think, science or career mode does cost science points to load your tanks, or you can actually harvest it from a different couple places. I think you can get antimatter from clouds around Kerbal, or maybe even Joule's atmosphere using this particle scoop part. Anyways, I might make a tutorial in the future on how to do this, but I've never actually done it myself. I just thought I'd mention it. And there's a couple other parts included with Far Future Technologies, like some prospecting science parts to detect these clouds of antimatter around like the sun and Joule's atmosphere that you can collect. There's also some bulldozer style harvesting parts that you can use to collect and smelt helium-3, collecting it from the surface of the Mun or other vacuum objects in space. Never tried it before, but maybe in the future I'll make a tutorial on how to do these harvesting of different Far Future Technologies fuels as well. But I will also link a really good guide that I found on the KSP forums on maybe a more deeper look into Far Future Technologies and the specifics of how it all works. I'll link that down below in case you guys need any more information. And of course, like I said before, I'll also include all the craft files you saw today that you can use as reference points or, starting points to build your own spacecraft using Far Future Technologies. But that's going to be about it for me today, guys. Thanks for watching, and make sure to leave a like, comment, and subscribe if you enjoyed and want to see more KSP content like this, and I'll see you guys next time.